Hey Titans, this is Mr. Sturts. We're on lesson 9.3, which is solving quadratic equations using square roots. So grab those student journals, grab your notebooks, wherever you take notes, and here we go. Alright, there's one definition we want you to get down here, and that is the definition of a square root, which is a value that, when multiplied by itself, gives us that original number. So a value that, when multiplied by itself, gives us that number. So our core concept kind of dealing with that idea is we have a variable squared equals a number. What we need to do is try to figure out how we can get that variable by itself, or how we can get rid of that squared. So the first one here, it says when our number is greater than 0, and we have x squared equals d. So for example, we had like x squared equals 4. This is actually going to have two solutions, because how we get that squared out of there, or how we cancel out that squared, is we're going to square root both sides. And when we do that, the square root and the squareds kind of just cancel each other out. We have our x left, and the square root of 4 we know as positive and negative 2. Because 2 times 2 is 4, and negative 2 times negative 2 is 4. So we have two answers there. Our second one, when d is 0, so when that number on the right side is 0, it just has one real solution, and that solution is 0. Because if we take the square root of 0, we're going to get 0. If we have x squared equals 0, well, the only number we can square to get 0 is going to be 0. So we just have one solution. And the last one is when d is less than 0, so when d is negative, we're going to have no real solutions. We cannot take the square root of a negative number if we think about x squared equaling negative 2. And we've talked about before, we can't square any number to get a negative number. No number squared is negative. So that's just going to have no real solutions. Alright, let's do a few examples. We need to get x by itself. So we're going to start off, we're going to use our reverse order of operations. Let's go ahead and add 27 to both sides. When we do that, we get those to cancel out. We have a 3x squared equals 27 now. We're going to divide by 3 on both sides, because we're doing our opposite operation. So we have x squared equals 27 divided by 3 here. Okay, and if we do 27 divided by 3, we're going to get 9. Now we have that variable squared equals 9. 9 is greater than 0. So if we take the square root of both sides to kind of cancel out that squared there, we're going to be left with x is equal to a positive and a negative 3. Don't forget, we have two solutions. We have one positive and one negative. Alright, so we have actually two solutions there. Alright, example B. Do the same thing here. We want to get that x squared by itself on one side, so let's do our opposite operation. So we're going to add 10 to both sides. We have a negative 10 and a positive 10, which gets us to 0. So if we think back to our core concept before, if we take any number squared, the only number that we can plug in for x there that would make it work, make it true, is going to be 0. So we just have one solution, and our solution is x equals 0. Just one solution there. Alright, and for part C, same thing here. We're going to do the opposite operation, so let's subtract our 11. So we're left with negative 5x squared equals 5. And we're multiplying here, so if we do the opposite operation and divide by our negative 5, we have x squared equals a negative 1. And remember what we said with negatives, we can't square any number and get a negative answer. So we know right away that this has no real solutions. So we have no real solutions there. Whenever that number is negative, we're going to have no real solutions. So there's our kind of three types of examples. When d is positive, we're going to have two answers. When d is 0, we have one answer, and that answer is 0. And when our d is negative, like right here, we have no real solutions. Alright, slightly different here. Okay, we're still trying to get that x by itself. Now we have kind of a quantity squared. We have that x minus 1 in parentheses squared. So if we just rewrite the problem here first, equals 25. We're going to use the same idea. We want to get that squared out of there. So a way we can do that is basically just square the entire left side and the entire right side. Remember, whatever we do to one side, we have to do to the other. Now we know that that's square root and that cancels out the squared. So all we really have left is x minus 1 equals positive and negative 5. That's very important. Don't forget that there's two solutions there to the square root of a positive number. Now this really turns into two problems because we have to have one with our positive 5, one with our negative 5. So if we go to solve that, x minus 1 is 5 and x minus 1 is negative 5. This is how we're going to get our two solutions. So now we're just solving for x. Add 1. So x is 6. Add 1. So x is negative 4. So there are our two solutions. So when we have a quantity squared, we don't need to panic. We can just square root both sides. The square root cancels out our squared. And then we know we have two answers on our right side. So split it into two, and we'll get our two solutions there. All right, a couple examples here. If we work through these quickly, we just divide by negative 3 here. So we're left with an x squared equals a positive 25. Take the square root of both sides. So we're going to have x is equal to a positive and a negative 5. All right, second one here, we're going to subtract 12 on both sides of the opposite operation. We're going to be left with x squared equals negative 2. We see that negative number on the right side, so we instantly know that there are no real solutions. And number 3, we have a quantity squared, so we're going to square root both sides. And when we do that, we're just left with 2x plus 1 over here equals positive and negative 6. And this is where we need to branch off and do two problems. We have 2x plus 1 equals positive 6. And 2x plus 1 equals negative 6. And now we're just solving for x. Let's subtract 1. So we have 2x equals 5. Divide by 2 here, and we're going to get a fraction, which is okay. One of our solutions is 5/2. And if we kind of squeeze this in on this side, we're going to subtract 1, so we have 2x equals negative 7. And divide by our 2 there, so we have x equals negative 7/2. So there are our two solutions. All right, moving right along, kind of our last idea here. It's not always going to be perfect. We're not always going to have perfect squares like that. And when that is the case, that's fine. We're just going to use a calculator and finish them up. So we're going to approach this the same way. Okay, this is a quadratic equation. Let's go ahead and work through this to get x by itself. So we're going to first add 13. So we're left with 4x squared equals 28. And we're still trying to get x by itself, so let's divide 4 here. So our x squared is going to be equal to, what do we get there, 7? Now, if we square root both sides, again, those kind of cancel each other out. So what we have left is x is equal to a positive and a negative square root of 7. Now, it's not a perfect square. We can't multiply two numbers that are the same, two whole numbers, to get 7. So this one we're just going to go to a calculator. And when we do that, we're going to have, if we type in the square root of 7, we're going to end up with a positive and a negative. Don't forget that positive and a negative, 2.5. Or 2.65 there. 2.65. Okay, so still two answers. Don't forget that plus and minus, very important. All right, last couple examples here. Let's go ahead and subtract our 8. So we have x squared equals 11. So if we take the square root of both sides, we see again we don't know the square root of 11. So we're going to use a calculator. And if we do that, we type it in and we get plus or minus 3.32 it looks like. Alright, example 8, we're going to add 2. Add 2 first, we get 5x squared equals 2. Divide by our 5. So we have x squared equals 2/5. Alright, and we're going to again go ahead and type that into our calculator. When we take the square root of both sides, we have x is equal to a plus and minus 0.63. And our last one, let's go ahead and add 30 to both sides. So we got 3x squared equals 34. We're going to divide by 3. And 3 actually doesn't go into 34 evenly, so we're going to have to leave it. And if we take the square root of both sides, we have 34 over 3. Type that in the calculator. x is equal to plus or minus 11.33. All right. That's all the material we have in this section, so now open up your student journals to page 289. Please give these problems a try. Number 4, 5, 15, and 20. Give them a shot. Look back through the examples. I know you can do this. Bring them to class tomorrow, and we will look over them. Have a great rest of your night.